Okay, so let's solve this system of linear equations here using the substitution method. We're going to be solving the system of equations here, x minus 2y equals 3 and 2x plus 3y equals 13. Now, since I don't want to graph this just to get the solution, I want to use substitution, which means my first step is to take one of these four variables, the x or the y in either equation, and get it by itself. So when I look at this, I think about the easiest one to get alone, and it's probably this x right here because there's no coefficient with it. And so what I'm going to do is I'm going to take this equation, I'm just going to write it again, and I want to get x by itself. So to do that, I solve it like a literal equation, and I get x equals 3 plus 2y. And so what I'm going to do, because I'm using substitution, is I'm going to take this, and specifically the expression of 3 plus 2y, and plug it into my other equation in place of the x. And so this whole expression here is going to replace my x here, because x is the same as this x. And since this x equals 3 plus 2y, I can substitute in. So this is going to bring me to 2, and then I'll use parentheses. 3 plus 2y plus 3y equals 13. You can see that all I did is I rewrote this equation down here, but replaced my x with 3 plus 2y, because this statement tells me that those two things are identical. Now we'll use the distributive property, and that brings me to 6 plus 4y plus 3y equals 13. I'll combine these like terms. 4y plus 3y is 7y, and at the same time I'll subtract 6 from each side, leaving me with 7y equals 7. And now my final step to solve for y is to divide each of these by 7, which means y equals 1. Of course, I'm not completely done yet. I need to take this y equals 1, and I'm going to plug it back into my expression here. I'm going to actually be able to say x equals 3 plus 2 times 1. Quick arithmetic will show me that x equals 5. And so I have my two parts of my answer, but my final answer I want to write as an ordered pair. And so the ordered pair is always x before y, in this case 5 before 1, and that's going to be my final answer. I can check it either using a graph or by plugging this ordered pair into my two original equations, and you'll see that they'll end up being true. 5 minus 2 times 1 equals 3. That one's true. And 2 times 5 plus 3 times 1 does equal 13. And so in both cases, it works out perfectly, which means that 5, 1 is indeed my answer. And that's substitution. Alright, so here we have a graphical representation of the problem we just looked at. The graph of x minus 2y equals 3, which is actually this line right here, and the graph of 2x plus 3y equals 13, which is actually this line right here. So we've used GeoGebra to graph this. You can see the two equations are written in here, and we found their point of intersection using our intersection tool, which they meet at the point 5, 1. You can see that's this point right here, x coordinate of 5, y coordinate of 1. And that point is the same as the solution that we found to the system of equations. Those values of x and y satisfy both equations and therefore are the solution of the system.